We have an Addams family. When the ball goes into the chair, it doesn't kick it out. It's in attract mode, so even when it's in attract mode and I put a ball in there, it should kick it out. It doesn't. So let's go into test. You can see that there's a credit dot. Did you see that next to the free play? At the end of free play, there was a little dot. That means that the game thinks that there is an issue. That's how you can just walk up to any game and see if the game thinks there's any problems. It's known as a credit dot or a test report. Anyways, so when we hit enter, here's our test report. Bookcase Opto 1. But that's the only test. So let's, or the only test report. Go into switches. Lift the playfield. So here's the chair kick out, and with the game and switch test I can manually activate it and see that it doesn't work. And in addition, there's a couple pop bumpers that don't work, or one, not that one, not this one here. This pop bumper doesn't work, all the other ones work. So what do these switches have in common? Well, they both have a white with an orange trace right there. White with an orange trace. Over here, white with an orange trace. So if I go to the manual, and if I look, white with an orange should start button. Let's try the start button. No worky. Let's see, care checkout, we know that doesn't work. Bookcase Opto, we know that doesn't work because it was complaining. Thing eject lane and swap lock lower. The swap lock lower is up here, and again that's a white with an orange. That doesn't work either. So it looks like everything in this same row is not working. So this is implying that there might be an issue on the CPU board. Back box open. Go to the CPU board. You can see all in here. Look at all the green. So look, somebody put a new battery holder in with nice new Duracell Pro Cell batteries. But look at all the greening they didn't clean up. What, they had to socket a couple chips, probably because of battery corrosion, but they didn't address it down here. So I suspect on the row connector for row 3, we have a broken line that we're going to have to fix on the CPU board. Okay, so I've got my meter out, set to test tone. This is the row connector. These two are in parallel, so these two should go together. So the first pin, pin 1, is also conveniently row 1. So if I put my meter on there, on row 1, and go up to the, you can see that there's little diodes across there. If there's a cap, then a diode, a cap, then a diode. Well, it should go to the bottom of the diode. So there's row 1, going from the connector up to its diode. Here's row 2, up to its diode. Here's row 3, and look, no connection. Just to keep going, 4, 5, 6, 7, and row 8. Where's row 8? Look, row 8 is out too. So we've definitely got some corrosion issues here. And that's, again, they replaced the chips up here, but they didn't address the corrosion down here. Okay, so what I've done is I just tagged a little wire wrap wire from the row connector onto its associated diode. I did wire brush this area, and then I took my clear fingernail polish and brushed it all over the resistors and the circuit board, because what this stuff does is it seals out air. It'll help prevent corrosion from coming back, because short of bead blasting this with, obviously I don't carry a bead blaster in the car to go do repairs, corrosion is very invasive, and it'll come back even when you think it shouldn't. Let's retest pin 1 to the first resistor, or first diode. Good. Pin 2 to the second diode. Good. Pin 3, this was the questionable one. See, now it's ringing. Pin 4, good. Pin 5, good. Pin 6, or row 6, and of course row 7 pin. Okay, and then row 8. Turns out that was just had a dirty spot, so that wasn't really broken. So now all our rows should be working. We could put it back in the game. Okay, CPU board back in the game. I am going to remote mount these batteries. There's no sense making this mistake twice. It wouldn't take much to send this board over the edge into a non-fixable corrosion zone. But anyways, got the game in switch test. First thing to check is that bookcase opto. Look, bookcase opto 1 now works because it's in that row. Now what about the chair kick out? That was the other one. Let's watch that as I'm just going to drop a ball into the chair kick out. Watch. Chair kick out works. And when I go out of a track mode, look, it kicks the ball right out. That's how it should. That's how the chair should work. So another thing was, let's see, the start button. That wasn't working. Now the start button works. Would have been pretty hard to start a game before without fixing this problem. So it looks like we're all good. We can actually play a game. Put the balls in. Okay, let's go. Notice free play has no dot after it, no credit dot. That means the game thinks all the switches are working. Doesn't think there's any problems. Here's another weird one. On row 7, white with a purple. So some of the switches are working and some aren't. I couldn't figure out why, but the weird thing is, like for instance, this is a stand-up target right here. When I press it in, nothing. But when I let it off, you hear how it reacts? Why is that? In, nothing, off, I get a reaction. It shouldn't be like that. Optos are like that, but mechanical switches aren't. And then down here, like the what is this, the thing kick out, that one's not working at all. But then there's one down here on the right loop that works fine. But the shooter lane one's not working at all. It's like weird. Something weird is going on here. Okay. Yet another problem. This is up in this area. This is a LM339 chip, which is again responsible for the rows. So remember we checked from the connector up to the diodes, but I didn't check which then the diodes go up to these resistors and then ultimately to the LM339. I didn't check everything that I probably should have. For instance, this particular LM339 controls 4 rows. So we should get, like on this resistor, we get there, and then this one I should get here, and I got nothing. And then on this one I should get here, and then this one I should get here. So we're still missing a line from here, this resistor right here. I got nothing. Yeah. So we still have a line out, another piece of wire wrap on the back. So the really weird thing about this, you can see I got it now. Here's the one that has a comparison, and then here's the questionable one. I now got tagged by just putting a little piece of wire wrap right on the bottom there. You can see my 2 wire wraps. Anyways, so how this manifests itself is the game would play fine for a while, but then after a little while, switches would start to not work. And that's what kind of brought this on. It didn't take long, but it did manifest itself. And this is the problem with battery corrosion. It's really tough to stop once it starts, unless, again, this is all bead blasted and all the corrosion is corrected. That's really the only right way to do it. And then after you bead blast, you always got to use a little clear coat just to kind of lock things down so they don't spin out of control, you know, from the air to help the corrosion. Because air is almost the enemy when it comes to this corrosion. Let's go! Now we've got a working game. This thing works right. It works on the push in, not on the push out. That was really just bizarre when it was doing that before. So like, look, it was on the in, not on the out. The in. It was doing that in reverse. This battery corrosion, it just does really weird things. This is why it's a bad thing. Get those batteries off the board.